Okay, so I'll be showing you um, how to create, you know, rigid bodies, active and passive rigid bodies. Um, okay, uh, for example, you might have seen dummy characters. For example, uh, when it comes to crowd simulation, okay, a lot many. Uh, it's called as, you know, like rag. Okay, it's a rag model or something. For example, mm, we can create some sort of any models, okay, dummy models, okay, instead of uh, animating all the characters. So we can play around with physics. We can create few objects as a passive object. We can create few objects as an active object. Okay, simple example. You know, domino, the domino cubes.
Sorry.
It's like
Yes,
domino.
sir.
Okay, you like that kind of animation. Let's say if one cube fall on another, how it will create an action. Okay, like that and all you can create. Let me just show you how does this work. And even bouncing ball animation and all, excellent. We can create beautifully with this. Okay. Uh, let me create. Okay, let me take a spear, a simple spear. I'm gonna place this spear somewhere here, and I'm gonna create a plane. Okay, I would like to make this as a surface, this particular plane, and I'll create mm, another plane, you know, something like this. I'd like to put, you know, place this somewhere here, like this. Okay, I'd like to create this one over here. Means I duplicate a plane and it's over here, and I duplicate this plane to the bottom like this. Okay, like this. What I'd like to do is I want the spear to, you know, drop from here to here. I want the spear to hit the surface, then it should slide on the surface, it should fall on this surface, it should slide on this, it should fall on this surface, and slide on this, fall on the ground. So you understand, you know, to do this in animation, you know, it takes a lot of time, right? At least to achieve a realistic output, it takes more than a day. Okay, but here it's just, you know, like within 5 minutes, less than 5 minutes. Okay, we just have to apply. These are the techniques actually. I'd like to extrude these models, you know, I would like to give bit of thickness. Shift right click, extrude. I'm extruding all these models. I'm giving bit of thickness. That's it, done. And this is the surface, means ground. Okay, I would like to extrude this one as well. Shift right click, extrude. Okay, done. Let me apply an existing material, that is Lambert 2. Okay, not Lambert 2. I would like to apply another material. So another Lambert I'll take, and let me apply red color or green color. Okay, let me take. Okay, great. So I have my spear. Now let me apply an material. You can see all the transform and activities will happen. Translate X, Y, Z, rotate X, Y, Z. Obviously scale won't happen. Okay, I'd like to apply new material. Let me go with blend and pick a color. That's a 2D texture. I would like to take checker so that you can see the uh, rotation part and all. Okay, great. So now if I play this, nothing is gonna happen, right? See, you can see it's moving, but nothing is happening. Why? Because I haven't applied anything, like it's just a simple model. There's no simulation now. We haven't added any physics. Now, I want you guys to tell me which one is an active body, which one is a passive body. Okay, I'll tell you.
Active.
Yeah, tell me. Yes, Lamini. Well,
The sphere will be active and then everything else will be passive.
oh man, very good. Sphere will be an active body. Rest everything would be a passive body. Okay, and a simple explanation. An active body is an object which performs an animation, which does need movement. And a passive body is an object which does support the movements or support the simulation or support the animation. It doesn't move, but it does support only. It acts as a passive body. Okay, for example, assume you're sitting in front of a table, and on top of a table there's a mouse, right? Obviously you have a mouse in front of you. Now mouse is, okay, if I push this mouse, okay, with one finger, if you push, it does move, but a force, an external force is allowing the mouse to move. Then your mouse is a active body, it's not a passive thing. Active in the sense some extra force is required for spear to fall down, right? You understood what I said? I want spear to fall down. That means I I can't do some magic, right? I have to apply some force for this particular spear, then only this will fall. Can you tell me which force I have to apply for spear? I want this to fall. So which force is required? Okay, simple.
Gravity.
Very good. Gravity. That's true. Gravity. Because obviously, in this word, gravitational force is there. So if anything goes up, it has to come down. Assume our sphere is somewhere here, it has to come down. So then I need gravity. But before that, we have to uh, decide which one are active body, which one are passive bodies. So basically these are rigid bodies. Whatever we are doing now, there are a lot many examples we can do on rigid bodies. This is a basic one. Okay, and of course you can use this for your showreel. Okay. Okay, I want this sphere to be an active rigid body. Okay, where are the rigid bodies? Go to fields and solvers. There are certain things. Create active rigid body, create passive rigid body. Before creating anything, you guys have to know, okay, what are the options right now, in the inputs what we have. So let's say, for example, if I select any object, what is the attribute, which are available right now, and what are the attributes which will be available after I convert this into an active rigid body. Now I'm selecting the sphere, go to fields and solver. There are two things. There are two types of rigid body: active rigid body, passive rigid body. I'm just applying an active rigid body. I have added active rigid body. You can see a rigid solver here. Click on the rigid solver. So there are many things here. So current frame, it will tell on what frame you are, and it doesn't mean uh, it will act from 129 frame. Whatever frame is there, it will act from that frame. No, it's not like that. I go to frame number 1. This particular thing, it is in frame number 1. That means any point of time this will react. Okay. Friction. See, whatever here it is there, these are really important. Let's understand this. Friction. Can someone explain what is friction? You might have heard this friction earlier also when I was working. Since I explained the flower pot, the fireworks effect, when the particle from one particular point, when it comes up and when it falls down, it used to tend to move. It tend to slide on the surface. So basically, friction is, it does create an effect where it reduces the velocity. Means when two objects collide each other, okay, when two objects move, get in contact in the movement, automatically friction produces. That means it reduces speed, it generates heat. Okay, so in physical environment, it generates heat as well as it produces velocity, which is nothing but speed. Okay, so what sort of friction is required, that we can see. Bounciness, of course, we know. Bounciness means once the rigid body hits the surface, the object will bounce. Okay. Then there's something called dynamics, display velocity. There are many things. If I go to attribute editor and click on rigid body, guys, you can see here. And if you come to rigid solver, you have rigid solver attributes, solver states, what and all is on, off, everything. Okay. Fine. So now I would like to make rest all of the things as a passive body. So select everything and you can apply, go to fields and solver, create passive rigid body. Okay. Now, when I play, yes, nothing is happening. Though I made this as an active rigid body and rest all other are passive rigid body, still nothing is happening because we haven't applied any field, right? A field is required, as an external force is required for the sphere. So I'm selecting the sphere, go to fields and solver. As you know, we need gravity, click on gravity. Now it's ready for the action. Let's play. See our sphere, excellent animation, excellent bounce, good rotation part, right? Let me play again. Observe. I'm selecting the sphere. Okay, let me deselect it. The sphere hits the surface. Again, this one and this one. There is a solid bounce also. Very good animation. Now tell me, to achieve this realistic animation, obviously it takes, at least for an animation expert, it takes a day, because we will be working on graph, each and, work on minute detail. But now less than 5 minutes, like we can finish off. Now I want, okay, now I want this particular sphere mm, to be more flexible. I want the sphere to be more flexible. Select the sphere, go to rigid body options here. Static friction, dynamic friction, bounciness, damping. So damping it plays very important role, wherein damping, it it's like a controller for the interaction. Now if I reduce damping, uh, oh man, it's gone. Means there's no control. There's no control over this character now. See? It lost its control. Then, see, it's gone away. Okay. Okay, let me see again. Lot of bounciness, lot of action. Again, hit back. Lot of action. Again, hit. It's like that. Okay, damping. Now I'll make it to 1. You should understand all these options. Okay. Okay, now what I'll do, I'll increase bounciness instead of 0.6 to 1, I'll make, and let me play. Now there's a lot of bounciness. Okay. I think, okay, damping, I need to make it 0. It should not be 1. Okay, now there's a bounciness. See, now bounciness is 1. Earlier it was 0.6. Now it's 1. See the simulation part. Okay. It looks nice. Now I select this. For example, impulse position, spin impulse. There's a movie called Battlefield, okay, wherein a spear shaped weapon will be there. Okay, you just check that, you refer that. See how does it work. For example, in x-axis, I'd like to give in x-axis, I make it 1. Now this spear will start, spinning in x-axis. Observe, lot of spin is there. Now let's say I would like to spin this in some other axis. Let's say I make it 0. I make this in y as 1. Observe what is happening. A lot of spin is happening, right? It's like this. So I make it 0 again. Then damping. If I increase damping, so it does control the movement. Okay. So a lot of now it adds friction. Okay, let's say if I make this damping as 1 and the bounciness is 1, it's okay. So now I can make this like an iron ball, iron spear. Much of bounciness won't be there. You feel the weight in this, right? It does have a lot of weight. Now, damping, I make it 0, and bounciness, I make 0.5. Okay. And by default, static friction means there will be some amount of friction will be there. Okay. Now, bounciness. Okay. See a lot of bounciness. Okay, I make bounciness as 1. There's one more element in this, mass. Mass is nothing but weight. Okay. Now I can increase. Now let's say this is of 1 kg. Okay, 1 kilo. I can make this into 100 kilo. Okay. Now the weight of this object is more. Okay. When the weight is more, you get this sort of simulation. Okay. Let me create something else. Okay. Okay. Let's say, okay, let me have a new scene. I'll just take a plane from here to here, and I'd like to give a thickness. I'm extruding this a bit, and let me create another plane. Let me create a cube. Cube somewhere here. Guys, this is a cool example. If you can achieve this, it will be really good, and you will enjoy working this one. I'm creating a domino effect. Okay, I have a domino cube, and I'm duplicating this over here and shift duplicate. I'm creating multiple cubes of domino. Shift D for instance, duplicating. Great. Okay, there are so many domino cubes, right? And I'm creating a plane. And this plane, I'm placing it over here, and I'm rotating like this, like this. And I'm creating a spear here, over here. Okay. Now tell me, Which one should be active body and which one should be passive body? I want you to tell which one will be an active rigid body and which one will be passive. Just think.
The sphere and the dominoes will be active, and then the planes will be passive.
Good, Lamini. Because there will be an external force here. Obviously, I'm going to apply gravity for the sphere, and all other domino cubes, the sphere is going to hit on the cube, and the cube should, do rest of the action. Okay. So now I'm selecting all this except these two. I'm selecting all the domino cubes as well as sphere. Go to fields and solver, create active rigid body, and I'm selecting these two. Go to fields and solver and passive rigid body. Now we should apply gravity for sphere, right? I'm selecting sphere. Go to this fields and solver, apply gravity. Now let's see how does this looks. Sphere is hitting the surface and it does hit on a domino, but what is happening? All these dominoes are, like it's on the air. So is it okay? Is it correct? Is this correct?
No.
So then what we have to do? Obviously we need gravity for this dominoes as well, right? We need gravity for the dominoes as well. So I'm selecting all the dominoes and I'm applying a field gravity. Okay. Now let's see what happens. The sphere hits the surface and bounces and hit a domino. Wow. Look, it does look good. And one thing, these dynamics, especially these rigid bodies, take a lot of memory, system memory. Okay, no need to worry when the system get freezes or anything. No need to worry. So the best part to execute this, the best part to capture this is, what you have to do is double click on this. So as I was saying, it did freeze. You have to go for a play blast. Okay, that's what I meant to say. Means you have to right click, go for a play blast. Okay, so press escape, if there are some issues. Okay, see now a lot of movements has happened. Right click, you can go to play blast, and I increase the quality to 100, scale to 1. Okay, I can save to file. I can browse, like let's browse and let's save this. Maya Dynamics, new folder, rigid bodies. Okay. Now you see, it's increase, it does perform the action. And anyhow, we are capturing this as a video. Once in the final output, it looks really good when you watch the video. And the best part is, like now the sphere, the mass of the sphere is 1. What if I increase the mass of the sphere to 100 or 1000? It's like one big, one huge kick. Okay. So these dominoes will fly away in that case. We can do a lot of testing. I'm going to press escape and I'm canceling this play bar. Okay, so I can see the video also. See, it's clear. Now in the video, it is really clear. Okay, so now I'm selecting this sphere. I'm gonna increase the bounciness to 0.8 and mass to 100. The weight of this is 100. Now let's see how does this looks. So it did hit. It is bouncing. Oh, great. Okay, so like this sort of movement. Okay, so now I'm gonna increase the bounciness to 1, and I'm gonna increase the mass to 1000. Now the 1000 kilo weight for the spear. Just observe, it directly hits on this particular object. Okay, means that push is there, because the weight is more, right? Already few of the dominoes are flying. So let's see. So to have a proper output, to achieve a proper output, always go for play blast. Okay, it does look good. I'm selecting this one. Anyhow, this is 1000 bounciness. I make 1.5. Now check. It does hit, and somewhere here it will bounce, and this scatters now. Oh, great. When this hits here, these dominoes will, it will come somewhere here this side and here this side. So to, to have an output, to see the output, it's better to go with a play blast. Okay, see, I press escape to see, how does this looks. This is what, this much push this spear has given. Okay, bounciness to 2, right click, play blast. Okay, it does hit, and somewhere here it will jump because bounciness I have given more. So again it will hit here. The bounciness is 2, so double the height is it is jumping. But when this hits this surface, these objects, it will, like scatters. It should. Yeah, this is where it is taking time, but it does capture. See, it's flying away. It's like a blast because 1000 kilo, and see the other dominoes also, because of this weight, it is pushing, all other object quite fast. It's like an experiment, like you can achieve different sort of outputs. And it's like a treat to watch. Okay, I'll just press escape. Let me see the video. In the video, you see real time. Okay, great. It's a blast. See, it's really nice. Okay. So try achieving, this sort of output. Okay. Come up with the different themes. For example, you can create some circular shape like a spiral object. Okay, and you can add a spear. Let the spiral object come inside and hit one object, and that hits another, and that hits another, like that. And even you can create, you create a snooker board, add multiple balls, and with the stick just give a push to the stick, from one axis. So let it hit and you see all of the ball, how does it go, and capture this particular, action and all, okay, with Play Blast, and share that as an output. Okay, any doubts, team?
No.
You can create snooker board, you can create carom board, lot many, create a domino example. Okay, you can write place dominoes in such a way that when it hits everything, it does form a name. Like that also you can do. Okay, you can try all that also. So try snooker board, it's really fun. Okay, fine, then reach out to me if you have any doubts. Okay, I'll share this video. Okay.
Yes.
Yes,
Okay, guys, great. And another update, I have already shared the theory part of this augmented reality and all, and projection mapping. Reach out to me if you have any doubts on that. And hopefully your exams might be on next month, second week. Okay, I'm just giving a hint, next month, second week. So be prepared for that. Okay.
Okay.
In the meantime, try to complete all the assignments and share the assignments with me. Okay. Okay, then. Okay, guys. Bye. Have a good day.
I see. Thank you.
Bye.